Well, good afternoon everybody and welcome along to April's session of DBA Fundamentals Down Under. My name is Warwick Rudd and I'll be hosting this session today. And in today's session we've got Glenn Berry from SQL Skills talking to us about analysing IO subsystem performance. Before I hand over to Glenn, I do have a little bit of housekeeping for you. So we'll just run through, just to let you know, first off we want a shout out to our sponsors, SentryOne. Without our sponsors, we wouldn't be able to hold these sessions. It makes it a lot easier for us to put them on so that you get this great content. With that, if you haven't already gone to SentryOne's website, make sure you do. They have some fantastic downloads and articles and tools for you to use to help in your SQL Server environments. Make sure you go and have a look at those to learn from some of the guys at SentryOne. I just want to let you know that today's session is being recorded. After today's session it will be made available up on the archive site of the Fundamentals Pass website. So feel free to come along to that so that you can re-watch this session at any point in time. I just want to make a call out to our local SQL Saturday event which is coming up next month here in Brisbane. Registrations are open. We do have a pre-con available, Zero to Microsoft Power BI by, that's the wrong link that's there, I need to update that, by Peter Myers. So feel free to register for the Power BI session and come along to a great day of learning from some magnificent speakers in the industry. You're already in associated with Pass, but there are many virtual chapters available for you to be part of and learn from. So make sure that you do go to the SQL Pass website and see those virtual chapters that are available. Also stay up to date with other events that are happening in our environment. So with that, I'm now going to hand over to Glenn and we'll get today's session rolling.
All right, thanks for the introduction. My name is Glenn Berry and I'll be giving this presentation today. This is Analyzing IO Subsystem Performance. And we're going to try to go through the slides relatively quickly and we have a lot of...
The broadcast is now starting. All attendees are in listen-only mode.
So anyways, my email is glenn@sqlskills.com, and if you have any questions that don't get answered during this session, feel free to send me an email and I'll definitely get back to you with an answer. This is a little bit about SQL Skills. And let me get on to the more important stuff. We do classes in the United States and also in Europe. And then there's a little bit more about me. And the most important thing is, again, my email and then my Twitter handle. Twitter is a really good resource, especially for beginning DBAs to get to know other people in the community. And it's also a good way to get questions answered with the SQL Help hashtag. And then I like to make beer, so I just thought I'd show you my beer making equipment right there. So anyways, and then finally, if you want to make my boss, Paul Randall, do a little bit of work, send him an email and he'll send you a free Pluralsight code that you can use for a month. And then I've got some other things from Microsoft at the end of this deck where you can get 3-month passes for Pluralsight. So you can watch Pluralsight for 7 months for free if you play your cards right. So anyways, what we're going to talk about today are the 3 main metrics for storage performance. And I'm going to talk about specific SQL Server IO workload metrics and some tools you can use to test your storage subsystem, and then talk about some of the primary storage types for SQL Server and talk about different RAID levels and how they're affected by different SQL Server workloads, and show you some comparative storage metrics from CrystalDiskMark for different kinds of storage. So the 3 main metrics for storage performance are latency, which is typically measured in milliseconds with most storage, input-output operations per second, or IOPS, and then sequential throughput, which is typically measured in megabytes per second, or if you've got really good storage, gigabytes per second. And these are all related, so you can't just look at one of them in isolation without knowing what's going on with the other ones. And the storage vendors, especially the SAN vendors, like to show whichever one of these that makes their system looks the best. So be aware of that. Now, latency That's just the time that it takes for an IO to complete. And depending on the tool you're using, it might be called response time or service time. And it starts when the operating system sends a request to the drive and ends when the drive is done with it. And the reads are complete when the OS receives the data. That's pretty straightforward. But the writes are complete when the drive tells the OS that it has received the data, and it might still be in a DRAM cache, either on the drive or in a hardware cache on a RAID controller or in a SAN cache, for example. Now, input-output operations per second, or IOPS, that's related to latency. And if you've got a latency of 1 millisecond, that means you can do 1,000 IOs per second with a queue depth of 1, which is pretty unusual for a server workload. Usually the queue depth's a little bit higher than that. And as you add more IOs to the queue, your latency tends to increase, especially with magnetic storage. And that's one of the main advantages of flash storage, is it can read and write to the multiple NAND channels in parallel. Plus there's no moving parts with flash storage. And so IOPS is just your queue depth divided by your latency. And it doesn't tell you what the transfer size is, which could be lots of different values. And you need to know what the transfer size is when you're looking at an IOPS measurement. So sequential throughput, that's the third one. And that's really the most important for a lot of things that we do as SQL Server DBAs. And again, with most storage that people deal with on production SQL servers, you're talking megabytes per second. But on good storage, it's gigabytes per second. And you just take whatever the sequential throughput value is, divided by how many you get per second, or it's the IOPS times the transfer size. That's what I'm trying to say here. And, so you can go from 556 megabytes per second with a 4K transfer size versus 1112 megabytes per second with an 8K transfer size that SQL Server used with the same number of IOPS. So knowing what the transfer size is really important. And sequential throughput quite often gets the short end of the stick in enterprise storage, mainly because of bandwidth limitations somewhere in the storage path. So it could be your HBA or your NIC or a switch, or just the underlying bottleneck in something like a PCIe slot or the drive array itself that limit your sequential throughput. And it may be that the disks in your system are so busy servicing other requests that they can't even deliver the full rated throughput. And that's fairly common with magnetic drives. And so why sequential throughput is so important for SQL Server is that things we do on a daily basis as DBAs, like full database backups and restores, initializing availability group replicas, initializing database mirrors, replication subscribers, and log shipping copies, things like that, are bottlenecked by your sequential throughput. Another common thing we do all the time is creating indexes or rebuilding existing indexes. And having good sequential throughput makes it so much easier to do things like index tuning. I mean, if you know that you've got a large table that needs an index, but you know that it's going to take 2 or 3 hours to build an index on that table, you're much less likely to try it and see if it helps your workload. Whereas if you've got really good sequential throughput and you can build an index on your largest table in just a couple of minutes, that really is a huge difference in how willing you're going to be to do index tuning, for example. And then another place where it comes into play a lot is with data warehouse or reporting workloads, where you're doing really large sequential scans from your data files when they don't fit in the buffer pool. So having good sequential throughput there is really important. So from SQL Server's perspective, there's certain things you want to look at and understand on your system. So the first really big thing to understand is what is the read versus the write ratio of your workload. And you can use my DMV diagnostic queries to help figure this out. And if you've never heard of them or never used them, just Google Glenn Berry DMV, and it'll take you to a page on my blog at SQL Skills, and you can download these for your version of SQL Server. And I'm going to show you a subset of these tonight, but these are really useful for finding out this particular thing and a lot of other things. And these read-write ratios are going to be different for different SQL Server file types, so data files versus log files, and different kinds of SQL Server workloads. But you need to understand that by looking at your live system. The next thing you want to understand is what are your typical I/O rates in terms of IOPS and throughput? So you can look at reads per second and writes per second in Performance Monitor, perfmon, and that gives you your IOPS at the disk level from perfmon, at the logical disk level. And then you can look at disk read bytes per second and disk write bytes per second in perfmon, and that's your throughput, again, at the disk level. So that's one way of looking at it at a higher level. Then you can go in and you need to find out what your latency is at the disk level. So again, perfmon can show you that. The average disk seconds per read and average disk seconds per write in perfmon is your latency. And I have one of my DMV diagnostic queries will also tell you that cumulatively since SQL Server's been running. And then you can drill in to the individual database files and find out what their latency is. And you can see that in real time in Windows Resource Monitor, or you can use another one of my DMV diagnostic queries to figure out what it is cumulatively for each one of your database files across your entire instance. All right, so some of the methods for measuring I/O performance. The first thing that I like to look at in real time is the disk section of Windows Resource Monitor, and that shows you the file level response time in milliseconds, and also shows you the reads and writes in bytes per second, so that's your sequential throughput. And you can sit there and watch that when you're doing something like running a database backup or building an index to watch what happens over time to the different files in your database. And that's really kind of interesting to watch, understand how your I/O subsystem is performing. You can also, again, look at the logical disk counters in perfmon to get latency, IOPS, and throughput with these different counters. And then there's synthetic disk benchmark tools. And the first one that I'm going to show you tonight is CrystalDiskMark. And then you can also run Microsoft Disk Speed, which is a little bit more involved, and it's driven by the command line or by PowerShell. And CrystalDiskMark actually uses disk speed under the covers, but it has a nice, pretty GUI that's really quick and easy to use. So here's what disk performance looks like in Windows Resource Monitor. And you can pull this up, off of perfmon or off of Task Manager actually, and watch it in real time and sort the columns and see what's going on when you're doing something to your I/O subsystem. So that's a quick and dirty way to see what's going on. Next, you can pull up these logical counters in perfmon, and these are the most important ones in my opinion. And then let's go out to SQL Server and actually do something fun here. And so the first thing I want to do is when you start showing some of these metrics that I'm going to show you later to your storage administrator or your SAN administrator, sometimes they'll just say, well, that's just a synthetic benchmark and that's not what SQL Server does, and the SAN looks fine to me. Go away, Mr. DBA. And so if you get that kind of feedback from your SAN administrator, this little query that you guys will have a copy of will help you, kind of show what the SAN actually is capable of doing. So that's why I call it how to humble your SAN. So the first thing we want to do here for this little test is just run a checkpoint, and that's going to flush any dirty pages that might be in memory. And then we're going to run dbcc drop clean buffers, and notice I say don't do this in production. This flushes out your buffer pool. And then we're going to turn on statistics IO and statistics time, both of those, because we need those for some calculations we're going to do later. And then we switch to a relatively large database, and I actually have a decent sized database here on my workstation. It's not AdventureWorks. It's fairly decent size. And then just to show you that we've got a decently sized table on here, we'll run SP space used. And this will show you that we've got 151 million rows here and about 18 gigabytes of data in this one particular table we're going to be messing with. And then here is the key little trick. You can just run a very simple query, select count star from the table, and you use this index hint to force it to do either a clustered index scan if there is a clustered index or a table scan if there isn't one. And by doing this, this forces it to read that entire table off of the data file or files into your buffer pool. And how long it takes to do that is going to show you exactly what sequential throughput you can get out of SQL Server for this database. And this came back in about 7 seconds. And if I go to the Messages tab, this shows me the elapsed time was 7,617 milliseconds. And then my I/O statistics right here show me how many reads I did. So I can get the read-ahead reads and the physical reads. So if I copy these and this back over here into this little equation, so this shows me that I'm doing 8 kilobytes per page, and then I multiply that times the physical reads and then the read-ahead reads, and then divide it by the elapsed time in milliseconds. And if I run this query, this will show me what my sequential throughput is. So it's 2,448 megabytes per second, which is quite good. And I'm using an M.2 NVMe SSD in my workstation, so that's why I get that kind of performance. So you can do that, and then we can do the same thing on another table that's using page data compression, just for grins here. And when I run this, this comes back quite a bit faster. And we could also get the same numbers from here and plug it into the equation and find out what we're getting from that. So the point is, you can do this on any large table you have on a real database on your actual system, and there's no disputing this is what SQL Server is doing, and this is showing what you're capable of getting in terms of total sequential throughput from that system. And of course, this depends on where the database data file or files are located and whether they're on separate LUNs and different underlying storage. But it's a real world practical example you can use. So what I really wanted to show you is this little set of queries. And these are sort of I/O focused diagnostic queries. And some of these are SQL Server 2014 or 2016 specific, but these are all kind of drawn from my complete set of diagnostic queries. So if you're running an older version of SQL Server, you could grab the older version of some of these queries from my complete diagnostic queries and build your own set if you needed to. So anyways, the first one in this set, I want to find out what's the name of my server and what exact version and edition and build it's running. So this shows me all of that. So I'm running SQL Server 2016 SP1 CU2, and I'm running Developer Edition, and I'm on Windows 10 Pro. And in real life on a production server, this is all very useful. I want to know if I'm on Standard Edition or Enterprise Edition. I want to know what version of SQL Server and what build, because that has a lot of effect on some of the other things we might be looking at later. All right, the next thing I want to know is what's going on with my global trace flags on this instance. And since I'm running 2016, a lot of the older trace flags that you needed to turn on, like 1118, for example, are already on by default. And so I only need this one, and this one just disables writing backup messages to the error log when they're successful. And that's one we recommend that people turn on, just to make your error log smaller. But if you're on an older version of SQL Server, you might want to have these other trace flags on for different reasons. And these can indirectly affect your I/O performance, some of these. All right, so the next one in the set is I want to understand what's going on with my hardware just at a high level, because this can also indirectly affect your I/O subsystem performance. So when I run this, I've got one physical CPU and I've got 8 logical CPUs. And I can't tell, unfortunately, from this query, do I have one 8-core processor or do I have a quad-core with hyperthreading, which is actually what I do have. But, and again, this is relevant whether it's a VM or not. And this tells you what the VM has or what your physical hosts have if you don't have virtualization in place. So I also see that I've got 64 gigs of RAM on my physical box, which is nice. And then it tells me when SQL Server last started. And then if you see hypervisor here, that does not mean that I'm running inside of a hypervisor. It just means there's a hypervisor on the host. And in my case, I'm not running in the hypervisor on this instance. I just have Hyper-V running. And then this tells me that lock pages in memory is enabled, which is a new column they added in SQL Server 2016 SP1. So moving on, I want to find out, is instant file initialization enabled or not? And I can get this from the SQL Server error log. And it turns out, yes, it's enabled. And that's good, and that has a big effect on your I/O subsystem performance, because let's let SQL Server skip the step of zeroing out your data file whenever it's created or grown. And this can be a pretty big deal if you've got poor sequential write performance to wherever your data files live. And this only works on data files, not on log files. And you can actually turn this on as part of the SQL Server setup process with SQL Server 2016. All right, so the next one is going to tell me what's going on with my sockets and cores and licensing. So this tells me in my case that I've got one socket with 4 physical cores and 8 logical processors total in this socket, and then 8 in the entire machine, and I'm using all 8 of them. And why this is so important to understand is if you are stuck using SQL Server Standard Edition instead of Enterprise Edition, well, depending on what version of SQL Server you're using, there's license limits for Standard Edition. So it's 16 physical cores with SQL Server 2012 and 2014, and then 24 physical cores with SQL Server 2016. And if you install SQL Server on a box that has more than that number of cores, it won't use any more with the license limit. And not only that, it's not going to lay them out evenly across your NUMA nodes by default. And then to make things even worse, if your server administrator went out and bought a brand new box that had, like, let's say 64 physical cores, and you're only allowed to use 24 for Standard Edition, well, Microsoft still expects you to license all 64 cores. So that would be a really bad, expensive mistake. So make sure that your server administrators don't do that just out of ignorance of how SQL Server licensing works. All right, the next one in this little set, I want to find out what exact processor I have. And so I've got a fairly new Intel Core i7 in my workstation, but on a real server, this will probably be an Intel Xeon of some sort, and knowing what that is really important so you can understand how old it is and what level of PCIe support it has, because that makes a really big difference for I/O subsystem performance, as you'll learn later. All right, the next thing I want to understand is what are some of my instance level configuration values that potentially affect I/O performance. So when I run this query, this tells me that automatic soft NUMA is disabled, which is fine. I only have 8 cores. If I had more cores in a NUMA node, SQL Server 2016 would divide them into soft NUMA nodes. Backup checksum default, I think that should always be turned on. That just makes it so that when you run a backup and you don't specify the checksum keyword, it automatically adds it on there and calculates checksums and checks them as the backup is running. And if the checksum is bad, the backup will error out, which is a good thing. And then backup compression default, that's usually a big win for most people. The exception is if you're under sustained CPU pressure and you can't afford the extra CPU for backup compression, or with older versions of SQL Server, if you're using transparent database encryption, then backup compression didn't work very well. But with SQL Server 2016, you can still use backup compression with TDE and still get decent backup compression. And the reason you care about backup compression from an I/O perspective is it's compressing the backup before it writes it to the backup file. And so it takes up less space, but more importantly, it reduces the load on your I/O system because you're writing out much less data. And so it also makes your backups and restores go a lot faster. Now, cost threshold for parallelism, it's set to the default value of 5 here. And for a lot of workloads, that's just too low. You'll get better overall performance by raising this to a higher value in many cases, but it's just something to consider. Max degree of parallelism limits how many cores can be used for a single query. And the default is 0, which means SQL Server can use as many as it wants. And what we typically tell people to do as a starting value is set this to the number of physical cores in a NUMA node. So if you had an 8-core processor, set it to 8. And the reason behind that, you're trying to keep SQL Server from using more than one NUMA node in a single query and having to do foreign memory access. So then the next one is max server memory. That needs to be set to an appropriate value so that the operating system is not under memory pressure. And then optimize for ad hoc workloads, the final one, that just reduces how much memory is used to cache ad hoc query plans the first time they're executed, and that can help reduce the plan cache bloating and help relieve memory pressure a little bit. So the next one, there's a new feature in SQL Server 2014, and it's in Standard Edition also, called Buffer Pool Extension. And in my case, I have it turned off. But what this lets you do is you can set aside space in your file system to cache clean buffer pool pages. And that means that they're data that's been read into the buffer pool that hasn't been changed. And if the data that you're trying to put in the buffer pool doesn't fit, and you have this cache file, then it can store it there. And with some workloads, this is going to help improve performance. It doesn't always help. And the ideal scenario for this is if you've got a relatively slow SAN with very poor random read IO performance, and you have your BPE file on very fast local flash storage, and if you have an OLTP workload, not a reporting workload, if all those things are true, then this feature might help you quite a bit. And it's pretty easy to try, and it's safe because if you lose this cache file, you don't lose any data, and you don't go down, and you don't have to have any redundancy for this. It doesn't have to be high-end enterprise flash either. So you can find out if it's turned on or not and where it's located and how large it is with this query. The next query, which I'm going to skip, would show you if you're actually using that BPE file and how it's performing. All right, the next one in the set is file names for all my databases and where they're located. So all the files for all my databases, how they're laid out across the file system, and how large they are over here. So that's good to know. You know, I've got multiple drives here in my workstation, and I've got things laid out fairly evenly. And you can see how many tempdb data files you have. So that's a nice query. The next one is going to show me how big my LUNs are for all of the LUNs that have any SQL Server database files. So when I run this, you can see here's my LUNs and what kind of drives they are, because I label them that way, and how large they are and how much space I have available. And not only is it a bad thing to run out of space just because you have problems if you run out of space, but as you get low on space, your performance tends to decrease, both with magnetic drives and with flash drives for different reasons. So having lots of available space on your logical drives is a really good idea. All right, the next one, I want to find out if I had any 15-second IO warnings. And this is going to look at the previous two, in this case, SQL Server error logs. And in my case, I haven't had any in the last two error logs. But on a real system, especially if it's not performing very well, you might have a whole bunch. And if you do see any here, you want to see, is there any kind of a pattern? Is it always the same files on the same drive? Is it always happening at the same time of day? Because it could be because you're doing something like rebuilding your indexes or running dbcc check db, and that's really pushing your IO subsystem really hard, so you're getting 15-second IO warnings when that's happening. Or it could be that you're just seeing really bad IO performance all over the place at different times of the day and with different files, and so that tells you a different story. But 15-second IO warnings are really hard to ignore. It's hard for your storage people and your SAN people to say, oh, that doesn't mean anything. 15 seconds is an eternity for a computer. So the next one is looking at my drive level latency for all my SQL Server database files that live on these drives. So this is rolled up to the drive level. And you can see this R drive has fairly high read latency. And that's because I was really hitting it hard with some queries before we started the session. But if I saw this in real life, I'd want to look into what's going on the R drive, you know, and what files are on there and how's it performing from other perspectives. So the next one does the exact same thing at the file level, so it drills into the individual database files. So when I see this, now I can see, okay, here's on the R drive, there's a database called no compression test, and it has pretty high read latency. And all the other numbers here are quite low, which is good, but this one is the culprit. You know, I was hammering that one on purpose in that query that I showed you earlier. All right, the next one in the set, I want to find out what's going on with my virtual log files, my VLF counts. And so every time you grow a SQL Server log file, it adds a certain number of VLFs. And the number that it adds depends on how big the growth was and also what version of SQL Server you're running. And you might be thinking, well, so what? Who cares? Well, if your VLF counts get high, it tends to hurt performance, write performance to your log file, but more importantly, it makes the recovery portion of a database restore take a lot longer. And it also comes into play every single time you start SQL Server because all your databases have to go through crash recovery. And if your VLF counts are high, crash recovery takes a lot longer. So that comes into play with traditional failover clustering when you failover from one node to another. It takes longer for the failover to finish if you have high VLF counts. So this will tell you if you've got a problem with that or not. All right, the next one shows me, okay, which of my databases on this instance are using the most I/O cumulatively? So when I run this, you can see this database is using the vast majority of the I/O. And these numbers are cumulative, by the way. So this is since SQL Server has been running, and it also includes everything that you've done, not just your regular workload, but index maintenance, running DBCC check DB, running backups, everything that touches that database. But now I can see this guy is the main culprit. All right, the next one in this set is the cumulative weight stats query. And when you run this tells you what SQL Server has been spending most of its time waiting on. And if your server is running really well, this is not as valuable, but if your server is running poorly and everybody's complaining like they like to do, then this will help point you in one direction or another. So in my case, this page IO latch shared is probably, it might be, IO related, but I wouldn't just assume that from the name. And I want to point out that this shows you the top weight stats, and then here's the percentage. So it spent almost 2/3 of its time waiting on that particular weight type. And then here's the average wait seconds broken down by resource weights and signal weights. So it's good to look at all that. And also, before you go crazy after you run this query and start changing things, you want to do a little bit more analysis and a little bit more thinking. And what I really recommend strongly is you go to my boss's SQL Server weight types library that Paul's been working on. And he's documenting, there's about 800 different weight types. And he's going through and slowly documenting every single one and tells you what they mean and what, if anything, you might want to do if you see that weight type. So I highly recommend you do that. Don't just run a Google search and then do the first thing you find from Google. That's called knee-jerk performance tuning. That's really a bad idea. All right, we're almost done with these queries, but this gives you the average task counts across all your schedulers. And you want to run this multiple times. And average task count here, the first column, if that's above 10 for any sustained period, that usually means that your server is either just really busy or more likely you're seeing lots of blocking and possibly deadlocking if you see this above 10 in most cases. If you see average runnable task count above 0 for any period of time, that means you've got tasks that are in a runnable state and they're waiting for CPU time. And it's sort of a secondary indicator of CPU pressure. And then this one's sort of self-explanatory. If this is above 0, it means you're waiting for disk IO to complete across all your schedulers. And you don't want this to be above 0 either. And you need to run this multiple times. Don't just run it once. So on a production system, this is going to be jumping around these numbers as you run it. All right. The next one is page life expectancy. And this is a Windows perfmon counter. And this tells you how many seconds data stays in the buffer pool before it has to get flushed out due to memory pressure. And the higher numbers are always better here. But you want to watch the trend and watch what the range is, because it's going to change based on what's going on with your system. But higher is always better. And if you're under memory pressure, that's going to put more pressure on your IO subsystem, especially from a read perspective. And if you're having really poor IO performance, quite often putting more memory in the machine will relieve a lot of pressure from your IO subsystem and make everything run so much better. Memory is a very cheap Band-Aid. All right, the final one, which is database specific here, is going to show me the IO statistics by file for the current database. So when I run this, remember I told you need to understand what kind of workload you have and whether it's read heavy or write heavy. Well, here we go. Here's the number of reads and the number of writes. And it also breaks it down in percentages and then megabytes read and written. So by looking at this, this is a very read-heavy workload, especially for the data file. The log file is almost even in this case, but it's good to understand that instead of just guessing what kind of a workload you have. So that's the complete set of those queries, and you'll have a copy of this. I've given this to Warwick so everybody can get a copy of that. All right, so we'll get back into this. And what you quite often see when you run all these queries is high write latency to your tempdb data files. That's a very common scenario that I see on production systems. And if you see that, then think about using local flash-based storage for tempdb if you can, if your workload needs it. And then the other thing you often see, or you often should do, I should say, is make sure you've got multiple tempdb data files. And the current guidance from Microsoft via Bob Ward is to start off with 4 to 8 data files and make sure they're all the same size. That's really important. And also you want to make sure you're using trace flag 1118 unless you're on SQL Server 2016, which turns that on by default. And the reason you're doing all this is you're trying to avoid what's called allocation contention. It's not really an IO bottleneck. It's the fact that all the schedulers are fighting to get access to a single data file to create and destroy objects in tempdb. And it's also very common to see high read latency from your user database data files. And if you see that from my queries, then you want to look for signs of memory pressure, such as low page life expectancy. And if you see that, one quick fix is just putting more RAM in the machine or giving more memory to the VM. But if you don't want to do that or you can't do that, then doing standard workload and index tuning to make sure you don't have any missing indexes, make sure you're not pulling back more data than you need to, things like that can have a big effect on memory pressure, and that's going to take pressure off your IO subsystem. And then, especially if you're using SQL Server Standard Edition instead of Enterprise Edition, buffer pool extension might work for you. It depends on your workload. But if you're going to do that, make sure you use local flash storage. Don't put your BPE file on a magnetic drive or put it somewhere out on the SAN, because that defeats the whole purpose of it. All right, CrystalDiskMark is a free tool you can use to test all of your logical drives. And one thing I always want to do whenever I'm building a new system is before I even install SQL Server, run CrystalDiskMark on all my logical drives just to see how they perform. And it doesn't work with mount points. It only works with non-mount point, just logical drives. And you want to test each one of them, again, before you install SQL Server. And you want to make sure that you test with a large test file so that the test file doesn't fit in your hardware cache if possible. And then you can also run this test with random and non-random test files so that you can see what might be going on with hardware compression with your storage subsystem. And then you want to make sure to run at least 5 test runs instead of just 1 so you don't have an outlier skewing your results. So here's what it looks like in the graphical user interface. And the top row here is sequential throughput with a queue depth of 32. And then this is random with a 4K transfer size and a queue depth of 32. And SQL Server does an 8K transfer size, but still, this is just for comparing. And it's for seeing what the entire drive can do. It's a quick and dirty test and only takes a few minutes to run. And down here in the text box, you've got to type in a description of what it is you're testing. CrystalDiskMark's not smart enough to figure that out. And you just pick what drive you want and the size of the test file and how many test runs you want to do, and click on this button here and just watch it for 4 or 5 minutes as it does its thing. And so it looks like this in the graphical. And then you can also get the text results, which give you more detail about the test. So it tells you the throughput up here, and then it shows you the random down here and shows you the IOPS, and that's what you care about, these top 4 lines. And then it tells you some more details about how big the test file was and when you ran the test and what operating system you were using and whatever you typed in that text box. All right, so I'll actually show you what this looks like on my system. So the first thing is that I've got a 6 terabyte magnetic drive in my system that I use for storing big things. And here's what a typical magnetic drive can do, about 170, 160 megabytes per second. You know, that's not too bad. That's sequential throughput. But where magnetic drives really fail, do really poorly, is random I/O. And so if you hover over this, that's 423 IOPS that I can get for reads, and a little bit better for writes, 464 IOPS. So that's pretty pathetic, and that's a big deal for databases especially. So here's a couple of different flash drives that I have in my system. You can see the huge difference here. For sequential throughput, we're looking at about more than 10 times better for reads there. But then the big difference is down here, 187,000 IOPS instead of 423 IOPS. So you can see kind of the range here. And if you're wondering, okay, how do I get those text results? If you go File, Copy, and then paste it over here into Notepad, here's where you get the text results to give you more details. So I'm not going to make you sit here and watch the test, but just be aware you pull this thing up and then click on the All button and it does its thing, and you got to type in what you want down here. All right, so there's 5 primary storage types that are commonly used for SQL Server. So we're talking internal drives, direct attached storage, storage area networks, PCIe flash-based add-in storage cards, and then SMB file shares with either scale-out file servers or storage spaces direct. That's what these acronyms are over here. So those are the 5 main things that people usually use for SQL Server storage. Now with internal drives, especially if they're flash drives, these can be more than adequate for many, many workloads. And you can have up to 28 2.5-inch drives in some modern 2-socket servers. So that gives you lots of capacity and lots of performance. And these are really well suited for availability group node storage. So if you're using always-on availability groups and you've got individual nodes, you might have your primary using SAN storage and then your secondary read-only replicas on local internal drives, for example. And how big your server is in terms of your vertical form factor, 1U, 2U, determines how many drives you can fit in there. And typically you want to purposely pick 2.5-inch drives instead of 3.5 so you can get more drives in a smaller server. And if you're going to use internal drives, make sure you spend a small amount of extra money to get the best hardware RAID controller you can get for your server. It makes a big difference. Premium RAID controllers have faster processors and larger cache sizes, so they perform much better, especially if you're going to use a parity-based RAID level like RAID 5 or RAID 6 or RAID 50. So, and also if you're going to use flash storage, you don't want the RAID controller to be the bottleneck. Now, direct attached storage is very similar to internal storage, but you have the drives and an external storage enclosure with, again, anywhere from 14 to 24 drive bays. And if you're going to do this, you want to try to make sure you have at least one RAID controller in your host machine for each storage enclosure, and you might even want to have 2 in some cases. And you want to make sure these enclosures have dual power supplies instead of just one, so you eliminate a single point of failure. And direct attached storage is really easy to configure and manage. It doesn't require any special training. It doesn't require a cranky SAN administrator either. Even a DBA can do this. And these give you excellent sequential read-write performance, and they're really limited by your PCIe slot bandwidth or your RAID controller. And these are also well suited for availability group node storage. Then with direct attached storage, again, you want to make sure you have one dedicated RAID controller per storage enclosure, and you might even want 2, and you want to make sure you use the very best RAID controller you can get. Usually When you go out to buy a Dell or HP server, for example, there'll be 3 or 4 or 5 different RAID controllers they offer for that machine. And the one that is the top of the line that has the largest controller cache and the fastest processor is what you want. And you want to make sure that the hardware cache is actually enabled on the RAID controller. With Dell servers, for example, they have a tool called Dell OMSA that lets you go in and create arrays in Windows. And if you do that, by default, that hardware cache that you paid the extra money for is disabled. And I've seen a lot of customers, they were running that way for years and they didn't know it. And just turning that on made a huge difference in their performance. And then you want to make sure that you've got your RAID controller in the correct PCIe slot and be aware of what that PCIe slot can do. And we'll get into that in a couple slides here. And then finally, you want to try to dedicate your hardware RAID controller cache to writes instead of reads, because the SQL Server buffer pool is your read cache. And your problem is writing to magnetic drives especially. Excuse me. So the way you can control this with most RAID controllers is to disable read-ahead caching, and that'll let it use that small amount of hardware cache for writes instead of reads. All right, PCIe slot, I've mentioned this a couple of times. Depending on how old your server is, you're going to be using version 1.0 or 2.0 or hopefully 3.0. And you can see this X4, X8, that's how many lanes, electrically lanes, are in that slot. So a worst case scenario with a server that's 4 or 5, 6 years old perhaps, you could be on PCIe 1.0 and an X4 slot, so the entire slot can only do 750 megabytes per second. And some modern flash drives can do more than that. So if you had a whole bunch of drives in a RAID array, then that PCIe slot is a major, major bottleneck for you. And where you want to be is down here. So you have much more sequential bandwidth that the slot has available. And how you get here is being on more modern processors. So here's where the PCIe version support comes in. If you want the latest and greatest version of PCIe, you have to be on an Intel Xeon E5 or newer for E5, so V2, V4, and V3 and V4, or on an E7 V2 or newer. So that's it. Anything else that's not on this list as of right now only has PCIe 2.0 or older. So that includes older E7s, older Intel processors, and everything from AMD. Now AMD has a new processor family called Naples for servers that's going to have PCIe 3.0, but that's not out yet. It's going to be out in probably another month or two. All right, so PCIe flash storage. This is just flash-based storage on a PCIe expansion card. It looks like a video card or a NIC, and it fits in one of your PCIe expansion slots. And it's got a very high bandwidth, low latency PCIe slot instead of using a SAS or SATA port. And the newest products that do this have a new protocol called Non-Volatile Memory Express, or NVMe, and that has much, much better performance than the older AHCI protocol that SATA and SAS use. And again, the type and the speed of the PCIe slot can be your limiting factor. So if you went out and bought a nice fancy card like this and put it in a 4 or 5-year-old server, you could be severely limiting the performance of that fancy storage card that you paid a lot of money for. And these things can replace dozens or more of conventional hard drives, and that can save you a lot of electrical and cooling costs and save you a lot of rack space. And if you're going to use these, it's a pretty common good idea to use 2 of them and then use software RAID 1 from Windows so you have some redundancy in the individual server. Now storage area networks, it's just an external storage enclosure with a lot of expensive components, and you have a large number of drive bays that you can usually expand if you're willing to pay a lot of money, and you have a lot of really nice features with SANs, but they are very expensive initially and they cost more to expand, And usually you got to have a SAN administrator that really knows what they're doing to get the best performance out of these. So I say the cranky SAN administrator is included free of charge when you get a SAN. And then there's two main types of SANs, fiber channel SANs with HBAs, and then iSCSI SANs that use Ethernet cards. And typically SANs are optimized for IOPS. And quite often their weakness, their bottleneck, is sequential throughput. And things you want to think about with SANs, look at the complete data path. So the HBA or NIC, any switches, any SAN ports, you want to make sure that they're all the same. There's not something in the middle that's limiting your bandwidth. And then you just have to be prepared for inconsistent performance with a shared SAN. Sometimes performance is pretty good, and sometimes it goes into the toilet for no apparent reason. And that's very frustrating for DBAs and users. And just be aware that SANs are not magic. The details of the SAN still matter no matter what that SAN vendor or salesperson wants to tell you. And again, SANs are usually sequential throughput limited. That's their Achilles heel. And then finally, DBAs and SAN administrators don't usually get along that well, but you want to make an effort to really communicate with your SAN administrator and befriend them if possible, and let them know what kind of workload you have. So it's a SQL Server OLTP workload. And don't just tell them, well, I need 5 terabytes of space for this new database. Give them some more useful performance metrics and SLA requirements. And keep in mind that they have totally different priorities than you probably do, because they've got to worry about multiple servers that all have different workloads sharing their SAN, and they've got to worry about running low on disk space, because then they've got to go out and spend a whole bunch of money to get more space. And they have to worry about people like me complaining about the performance, and they have to worry about the CIO complaining about how much it costs. So they're kind of, I don't envy a SAN administrator. All right, SMB file shares. If you're on SQL Server 2012 or newer, you can store your user and your system databases on SMB file shares. And that doesn't mean stick them on your file server somewhere on just a garden variety file server. I mean, technically that would work if you had a new enough version of the OS, but you need some special hardware to make this work properly. And this gives you an alternative to using a SAN for things like traditional failover cluster instances that require shared storage. And you need to be on Windows Server 2012 or newer, and you really need to have network hardware that supports something called RDMA, Remote Direct Memory Access. That's a special kind of NIC that has really good performance and very low latency. And there's a guy who works at Microsoft named Jose Barreto, and he has a whole bunch of blog posts that explain how all this works, and how you can play around with it in a lab, and how to get it to work with SQL Server. And a new thing that was introduced in Windows Server 2016 that a lot of DBAs haven't heard much about is called Storage Spaces Direct. And this is software-defined storage that lets you build storage clusters using commodity hardware and commodity drives. And you have multiple nodes in a storage cluster that's exposed to something like Hyper-V or SQL Server to use as highly available, highly performant storage. And this is more popular and more used right now with Hyper-V, but I think SQL Server is going to start using a lot more as people start to understand how it works. And again, it lets you use any kind of storage you want. And you can use SATA drives instead of just SAS drives. And you can combine magnetic and SATA and NVMe, and it'll automatically tier them and use them in the best way. And so it's pretty cool. And so here's some more references about Storage Spaces Direct, and talks about how to use it with SQL Server on a couple of these. All right, so we talked a lot about storage types, so now we need to think about your workload and what kind of a SQL Server workload you have. So you've got OLTP, you've got reporting against OLTP, you've got relational data warehouse or pure reporting, and then OLAP. Those are kind of sort of different kinds of pure workloads. And these all have different I/O access patterns. So the read-write ratio against your data files and your log files whether it's mostly sequential or mostly random reads and writes, those are all going to be different based on these workloads. And that one query I showed you at the end of the set helps you see that for a particular database instead of just guessing. So if you have an OLTP workload, that means you're going to have lots of writes to your data files and also to your log file. And you're also going to have very frequent reads from your data files if the entire database or the working set of the database doesn't fit in your buffer pool. So this means that random I/O performance is usually pretty important for OLTP workloads. Now, if you only have one database and the log file for that database is on a particular LUN, then you're doing just sequential writes to the log file. But it's more common for most people to have multiple databases on an instance, and they might have all the log files for all those different databases on the same LUN. And if that's the case, then your writes become much more random. So that's another reason you might want to use flash instead of magnetic in that kind of a scenario. All right, data warehouse and reporting workloads. What you're going to see there is just like that first demo I did, you're going to do large sequential reads from your data files. And so if your database doesn't fit into memory, then you're going to be hitting those data files really hard and doing these big sequential reads. And you're hardly even going to touch your log file except when you're doing data loads. So your sequential, especially read I/O performance, is really important for this kind of a workload. So that might change what kind of storage you choose and how you decide to configure it. Then if we're an OLAP workload, you're going to do lots of random reads from the cube files, so your random I/O performance is very important. And then when you're building the cube file, that's more of a sequential write typically. All right, so RAID levels and SQL Server workloads. Again, you need to think about what kind of a workload do I have, because that's going to affect your RAID level. If you know that you're doing lots of writes, for example, then you want to avoid the parity-based RAID levels like RAID 5 and RAID 6 and RAID 50, and you might want to pick RAID 10 or RAID 1 so you don't have that parity write penalty. And just understand that the different kinds of workloads we just talked about have different I/O patterns, so percentage of reads and writes, whether it's sequential versus random, and also the different file types. So whether it's a data file or a log file or a tempdb file or a backup file, it's going to affect what's happening to it from an I/O perspective. And that's also going to change depending on what's going on. So when you're running a database backup or if you're building an index, that's going to be a completely different I/O workload for your storage subsystem. And then think about what your availability requirements are for your databases, because some of the RAID levels are just more robust than others. So RAID 10 is more robust than RAID 50, and RAID 50 is more robust than RAID 5. RAID 5 is actually pretty brittle. You know, you can only lose one drive in an array, and then you go down after that. So selecting a RAID level for your SLA, you know, I kind of get on my soapbox here, but RAID is not a substitute for a good backup and restore plan. And I've had so many people in my career come up to me and say stupid things like, well, Glenn, the database is stored on RAID 5, so we don't need to do SQL Server backups because RAID will protect us. And that's ridiculous. You know, all RAID is going to do is keep you from going down, from losing one or more hard drives depending on the RAID level. So RAID's not a substitute for an effective HADR strategy. It doesn't matter what fancy appliance or software that somebody bought. You need to be doing your backups and make sure you're restoring them and make sure they're good backups. And so, you know, just don't give ground when somebody tries to pressure you, because SQL Server has a big target on its back. It uses a lot of resources and a lot of disk space, and people are always trying to come up to you and pressure you. Oh, don't do backups, we're doing this instead. No, backups are your final line of defense if everything else fails. So choosing storage types based on your workload type, flash-based storage gives great random I/O performance, and it gives you better sequential performance than magnetic, but the difference is not as stark as it is with random. And it can be the most expensive, but the prices have come down so much that it's almost the same. 15K magnetic storage versus entry-level enterprise flash is about the same price. Now, magnetic storage gives fair sequential performance, but it gives very, very poor random I/O, especially for writes. And that's why you see these big controller caches at the SAN level or the drive level or the RAID controller level to try to mask that. And so Flash doesn't have that problem to the same extent. And so Flash makes sense where you have heavy random I/O, or we're just seeing I/O bottlenecks of any sort. And so magnetic versus flash, you can see the different numbers here. You get typically 100 to 200 megabytes per second per disk for magnetic, for sequential, but where it really falls down is on random, 100 to 200 IOPS per disk. And that's really pathetic compared to flash-based storage. And flash, not all flash is the same. So there's different levels of SAS and SATA. So the very best SAS and SATA you can get now will do about 1100 megabytes per second, but it's much more common to use SAS or SATA level 3, which is only about 550 megabytes per second. And PCIe storage cards can do a lot more depending on how much you spend on them. But where they really excel is on their random I/O performance. So anywhere from 100,000 IOPS to more than 1 million IOPS on some of the very highest end ones. So remember I said flash storage is not all the same. You've got different kinds of NAND cells. And so typically, especially a few years ago, enterprise storage was always a single level cell, SLC. And that was the most expensive, and it has the lowest latency and the highest endurance, but it costs a lot. And so now you see a lot of drives that have multi-level cell, MLC, or even triple level cell, TLC. And those have higher latency but lower endurance, and they cost less. And so what you see in a lot of devices is they have a small amount of SLC as a cache in front of the MLC or TLC for the rest of the drive. And how they do this depends on what kind of market they're targeting. Is it meant for lots of writes, or is it for mostly reads? So not all flash is the same is kind of the point of this. And so there's different flash storage interfaces and protocols. And so this has a big, big effect on how they perform. So first of all, with your older drives, you've got it's either a SATA or SAS interface. And you've got the different levels, 3 gigabits per second, 6 gigabits, 12 gigabits. And these typically use the old AHCI interface, or protocol I should say. And that is severely limited. It was really designed for magnetic drives and not for flash storage. And what you want is to be using PCIe Express, and then you want to use this newer protocol, NVMe, that is designed for flash storage. It has much lower latency and it uses less CPU on the host. And the difference in performance is pretty amazing. So configuring your storage for SQL Server file types. For data files, most people are still using magnetic, but flash is becoming more popular. For log files, a lot of people will use magnetic unless they have multiple log files on the same LUN, and then they might want to use flash. But usually you want to use RAID 10 instead of RAID 5 because you're doing lots of writes, depending on your workload, of course. And then SQL Server TempDB, data and log files. Most people will use flash even if they might not need it. And it depends on your workload. Some workloads hardly use TempDB at all, and some workloads really hammer TempDB. So if you're using read committed snapshot isolation, that puts a big load on TempDB, and having flash storage can really help there. All right, if you're using any kind of HADR technology like database mirroring or availability groups or log shipping, that might affect your storage. And the big place here it really affects you if you're using traditional, old-fashioned Windows failover cluster instances. And there's really nothing wrong with that. That works well and people know how to use it. But that requires shared storage. And usually that means a SAN, but now you can use SMB file shares instead of a SAN. And one thing you can do if you're using traditional failover clusters is if you're on SQL Server 2012 or newer, you can move your tempdb files off of the shared storage onto local storage on each one of the nodes in your cluster. And that can be pretty inexpensive and give you a huge performance boost because you get better tempdb performance and you take the tempdb load off of the shared storage so the rest of it runs better. So if you can convince your storage people to let you do this, that can be an easy win. Now, availability groups have to use the Windows clustering feature, but they don't have to use shared storage. So again, you can use any kind of storage you want for availability groups. And then anything else you might be using for HADR, you can use any kind of storage you want. So you might want to purposely not use shared storage to eliminate that single point of failure that shared storage has. All right, sizing your storage subsystem. There's RAID calculators you can find online to make sure you have more than enough disk space. And especially with magnetic storage, if you have lots of available disk space, then you get what's called short stroking. So the arm that's moving the head back and forth across the platters to find your data doesn't have to move as far when you have lots of empty space, and that can have a huge effect on your performance. And then flash storage benefits from having lots of space because as you get low on space, it gets harder for the NAND to do what's called a trim operation and move blocks around to be contiguous. And that really hurts your performance as you get low on space. And then once you have enough space, then concentrate on performance. And don't make the mistake of negotiating with yourself. And what I mean by that is you might be thinking, well, the company's not doing very well or our capital budget's not very good, so I'm just going to ask for magnetic storage and make it all RAID 5. Don't give away the store without fighting. You've gone through and done your analysis and you can see that you really need good tempdb performance. So make sure you get the right kind of storage to support that. And if you really are under budget pressure and have no choice, then think about your workload before you just make everything the worst possible storage because you didn't even put up a fight. And you want to try to aim for at least 10,000 to 20,000 or more IOPS for each logical drive. More is always better. Nobody's ever come to me and said, oh, this database server is too fast, Glenn. I've never heard that ever. And you want to try to get 1 gigabyte per second or more of sequential throughput on every single logical drive because that gives you that good performance to do things like run backups and build indexes. All right, here are some comparative numbers for different kinds of storage. And you can see at the top magnetic drives, how they're fairly low and the numbers slowly get higher. But that's for sequential performance for these different kinds of drives for reads and writes. But the big difference is for random performance. You can see going from 790 IOPS to nearly 200,000 IOPS. And these are just drives that I've had my hands on personally and tested with CrystalDiskMark. There's other kinds of drives and other kinds of storage you can do that are much higher numbers in here, but you can see the huge orders of magnitude difference in numbers there. All right, so I just want to throw out a few new things that have just come out that you might not be aware of. The first thing is Intel has a new product called Optane, is their kind of marketing term for it, but it's a new kind of flash storage that has much lower latency even than NVMe flash storage does and has better endurance. And they just came out with the very first product about a month ago. And you could use one of these to do something like have tempdb on it, for example, if you needed the absolute best performance you can get. So I've got a link that talks about this. And then this shows you how much better Storage Spaces Direct performs with this new card compared to the very best flash storage that Intel had before that. And then there's another new thing called storage class memory. So it's a non-volatile DIMM that has flash storage and a little battery tied to it, and you put this in one of your memory slots. And then SQL Server 2016 has a new feature called tail of the log caching. So you create a little tiny log file that just the very tail that lives on one of these super fast storage devices, and then you can get much better performance writing to your log file. Now this is only important if you really have a bottleneck writing to your log file, but for some people this is a really big deal, and this is something you can get with Windows Server 2016 and SQL 2016. Excuse me. So just to review, there's 5 primary storage types for SQL Server. There's different kinds of workloads that can affect your I/O patterns, and there's different file types that have different I/O patterns. And you want to make sure you pick an appropriate RAID level for your workload, and then don't forget sequential throughput, because you're the DBA living with this on a daily basis. And quite often your storage administrators don't care as much about sequential. All they care about is IOPS or latency. All right, so I've got some references here. I've got 3 relevant Pluralsight courses that you might want to watch if you want to learn more about this. And then these last 2 links are free programs from Microsoft that you can sign up for and get a 3-month Pluralsight pass and a bunch of other good stuff for each one of these 2 programs. So I highly recommend you give that a shot. So that's it for the presentation. If there's any questions, I've got some time to answer them.
Okay, so Glenn, we do have a couple of questions, so I'll fire those at you. So for capacity planning for a new system, how do we answer the question from the server/storage team, what would be the I/O requirement for the database server?
This is for a brand new system or replace an existing system?
I guess we could just pick either or. We haven't got that.
Okay, well I mean, the easier answer would be if you're replacing an existing system, then you can run my queries and you can run perfmon counters and get an idea of what kind of numbers your existing system is doing. And then you would try to plan the new system to at least be able to support that, but ideally more, so more IOPS and more sequential throughput than what you're seeing with your existing system. But what your existing system is doing would be a bare minimum baseline.
Okay. What is the recommended throughput for SQL Server?
Well, I mean, that's a hard question. What I said in my presentation is I try to get at least 1 gigabyte per second on each logical drive. And if you have less than that, it's just going to make things harder for you as a DBA. And it's not just you, the DBA, but the entire system. So, if you've got a 1 terabyte database, does it take 10 hours to back up or half an hour? That's determined by your sequential throughput. I mean, there's things you can do to try to help like backup compression and having striped backups, but ultimately your sequential throughput, just controls how long it takes to do your common administrative tasks. And it's not just about making your life easier as a DBA, but imagine it's a disaster recovery situation where you're down and you're having to restore from your last full backup set. How long that takes to come back online, your RTO, is affected by your sequential throughput.
Okay. So this one goes to the check that you were looking at around the 15-second threshold. How was that determined and who chose the 15 seconds as a threshold?
Wow. Well, I don't know who chose the 15 seconds, but SQL Server is monitoring that, and if an I/O takes 15 seconds or more to finish, then it just logs that. And on a real live system that's not performing well, you'll quite often see, dozens or hundreds of entries in your SQL Server error log where it'll say SQL Server saw 5,000 occurrences of 15 seconds for this particular file, or just 1 occurrence. But yeah, I mean, SQL Server is the one that's recording it, and I don't know who just chose 15 seconds as a threshold. That's a good question.
Okay. Excuse me. Is trace flag 1118 applicable for SQL Server 2016?
No, it isn't. I mean, the behavior that turns on is on by default, and if you turn it on yourself, I think it actually writes an error message to the log saying that it's being ignored, so it gets no opt. but it's already in effect for SQL Server 2016. You don't need to turn it on.
Okay. Do I need to install CrystalDiskMark on the server, or is it a standalone executable?
It's a standalone executable. You go to a Japanese website to download it, and they have that you can download the portable version that just comes as a zip file, and you can take and expand that into its own folder with no installation and just run it. They also have another package that installs it, but I never use that.
Okay. So if we're installing or configuring analysis services, is it better to have the data, log, and temp DB files on separate drives, or can you just put them all on folders on a single drive?
Well, that depends. That question always comes up because a lot of SANs in particular, they will have a whole pool of drives, and then whatever logical drives you carve out share the underlying storage across the entire SAN. And so if that's the kind of SAN you have, excuse me, then dividing them to separate drives, like the more conventional strategy, doesn't really matter from a performance point of view, but I still like to do it because all the tools and a lot of the queries we use to look at things show you things by the drive. And so if they're all on the same drive, it's sort of harder to understand what's going on, even though with that kind of storage, it's all the same pool, so it doesn't really matter to separate it. So that's kind of my answer to that question, because a lot of times your SAN people will say, well, I don't want to give you 3 logical drives because it's all the same under the covers. I'm just going to give you 1. But I still would like to have separate just for visibility purposes as a DBA.
All right. Well, if there's no more questions, anybody, I'll take this opportunity to thank Glenn for coming along and presenting this session for us today. I'd like to thank everybody for coming along and being part of this session. The session for next month is up and available, so make sure that you go to the DBAFundamentals website, register for next session, and I look forward to seeing you all same time in a month's time. Thank you, everybody.
All right, thanks.